So on the next page, 353, we're going to take a look at, yet again, another Riemann sum approximation. And this time, instead of using a left endpoint or a right endpoint to help us estimate the height of this function, we're going to go ahead and use a midpoint. So it kind of has the same idea where we're going to find individual areas, we're going to add them up, but this time we're going to use a midpoint value instead of a left or a right endpoint corner value. And for this example, we're going to go from 1 to 7. Okay, it's yet again the same function as before, and we want a length of 2. So if I think about drawing in my first rectangle, I'm going to go from 1 to 3 because that would give me a length of 2. And I'm going to find the midpoint of that interval. So the exact middle of 1 and 3 would be the value of 2. So in that middle, I'm going to kind of drag my pencil up to the curve. I'm going to make my dot, and I'm going to go straight to the left, straight to the right, and then back down to connect my 1 and 3 location. So this time I'm drawing my rectangle not necessarily ending on the curve, but the midpoint is going to be on the curve itself. The next rectangle, if we need a unit of 2 for the base, would be from 3 to 5. The midpoint would be at 4, so I'll drag my pencil up, make my dot, go to the left, go to the right, and make sure that you connect the 3 and the 5 on the x-axis. The last interval would go from 5 to 7, middle is 6, drag my pencil up, make a dot, left, right, and connect the 5 and the 7 on the bottom. Alright, so it looks like in this case we have 3 rectangles to estimate the area under the curve. So not a huge amount of calculation here. So area of the first rectangle, our base is 2, and then the height that we're going to use is going to come from this midpoint, which had an x value of 2. So we have to plug in 2 into the function to get the height of that function. The next interval, or not interval, but rectangle rather, has a base of 2. Height comes from the function value at 4. So I'll have f of 4. And then for my last rectangle, base of 2, height came from the x value of 6. Alright, now since this is the same function, we should already have these values written down somewhere, or you can quickly find them on your calculator. So after you do that computation, you should get about 40.6667. Alright, now if we think about if this is an over or an underestimate, because after all these Riemann sums are approximations, we can start to visualize graphically here kind of what's going on. So here I have an overestimate. Over here I have another over, looks like over here I have another overestimate, but I also have some unders because here's some area under the curve that I did not include, and also maybe this section in here. So notice how we have a little bit of both. So this is where you might need to just kind of take your best educated guess as to which one is more. So I don't know, to me, just visually, it seems like I have filled in more of a black region than I did a red. So I'll go ahead and say overestimate for this one. Alright, let's try the same example, but this time we're going to do a midpoint Riemann sum with length 1. So we're going to go from 1 to 7. Our first rectangle would go from 1 to 2. The midpoint of that interval would be 1.5. So I'll trace up from that spot, make my dot, left, right, and then connect the bases. Okay, I'm going to repeat the pattern for all the other rectangles. Go from 2 to 3, and then the middle, 3 to 4, and then the middle, 4 to 5, in the middle, 5 to 6, in the middle, and then 6 to 7 in the middle. So we have 1, 2, 3, 4, 5, 6 rectangles this time. Alright, so my first rectangle has a base of 1, and the midpoint that we're going to use to calculate or use for the height came from the x value of 1.5. So I need to figure out f of 1.5. My next rectangle had a base of 1, and its midpoint came from the x value of 2.5. So it seems like we have a little pattern here. Maybe I'll just do dot, dot, dot. The last rectangle, again, base of 1, and the height came from the middle of 6 and 7, so that would be 6.5. All right, now I'm pretty sure we have these values from a previous example, so if you have those numbers available, go ahead and use them. Maybe you need to calculate them on your calculator real quick, but in the end, we should get something like 40.167. All right, so over, underestimate, again, we might have a little bit of both. It seems like we have a little bit of over here, might be a bit of over there, over here, over here, over here, over here. In terms of under, I can fill in those sections. Notice how the more rectangles we have, though, like we stated previously, the less obvious it is for the over and under little sections, so that just means we're getting more accurate. So, I don't know, educated guess, maybe a little bit over? Under? Maybe under. Who knows? Because it seems like I have more red filled in than I do black. So maybe I'll say this one's an underestimate. Okay, just an educated guess.